Hello and good morning, everyone. My name is Sebastian. I'm the novice prospect, and I'm just noticing I didn't have my subtitles enabled, which should now start appearing. Yes, good. Hello and welcome, everyone. We are back to programming. We are continuing in our endeavor to learn MonoGame. And let's remind ourselves where we got to yesterday. So make clean, make run, go and do the full thing. Yeah, I thought you might want a coffee.
Okay.
hmm And there we go. We basically have a game window. Okay, we have two animated sprites, and we can actually move our player character, our slime, so to speak, around. Right, but this is basically a very simple implementation because all we're really doing is during the update call, hey Ronnie, nice to see you. We basically, calculate the actual updates for the slimes and the bat, basically meaning we calculate the actual animations. And the way that works, well, if we just want to jump into this quickly, we basically just check through how much time has elapsed. Should we be at our next animation frame? If so, go to that frame. Otherwise, we'll stay at the current frame. If we have reached the end of all available animation frames, roll back round to the 0th frame, meaning go back to the beginning and just loop that animation. And that's basically all that does. And then right underneath that, we basically say, hey, go and check keyboard input, check gamepad input. And you can see literally here us just getting a state from the keyboard, and we're checking, hey, are we looking at the space being pressed or W or up? This is again where we're actually looking for both keys, either W or up. So it doesn't matter, but they both will end up moving the character up. Now in MonoGame, going up actually means going negative on the y-axis, because essentially everything starts at the very top left corner, and then on the x-axis you go over to the right, and on the y-axis you actually go down to increase. So for us to go up the way, we would need to minus y, minus the speed that we have defined, and that's all there is to it. So
You have to go down to go up.
yeah, mathematically.
All right.
So if you want to move your character,
Places.
if you want to move your character up, you have to actually go negative in numbers. Yeah, it's just this is always a problem in any graphics engine. You always have to define some sort of origin, and usually we like the origin to be actually, in our thinking, bottom left. Right? Because then if X increases, we go to the right, and if Y increases, we go up. Somehow, and I've seen this in OpenGL as well, they do the origin from the top. You still go over to the right to increase X, but to increase Y, you're actually going up again. Like it's weird. But once you know it, it's fine. Like you do get used to it. So, but so we have finished lesson 11. I have already went and done the branching off to chapter 11. Look at the difference using keyboard input as an example. With our current implementation, we can check if a key is down, because we're literally saying, keyboard state is key down. And that basically returns a true or false. Is key down? What key are we checking? And then you get a Boolean result. But we can do this differently. And this is what we're doing here. Basically, what we're saying, if the keyboard key space, for example, is pressed right now, but previous keyboard state was key up, then we know there's been a transition. And that's actually what we're looking for. We don't really care ultimately whether the button is just pushed. We need to actually differentiate between, has the button never been pushed, never been touched, and now there's constant input or is it being held input? But we need to look at that previous state as well as the current state, and this is what we're doing here. And this is just pseudocode. This is sort of a very small part of it, but we will see us making a full library for this. But literally, this is all we're doing here. We have a previous state, we get the current state, we compare the two states between the key that we're interested in, and also say, hey, the previous keyboard state is now equal to our current state. So we're actually updating that previous state every time just before the next update runs, right? And this is why we're now making a keyboard info class. Sweet. Let me go and do just that. And show. Okay. I had a feeling there was an extra file, but no, it's all good. So this is going to be a new folder, I believe. Yeah, let's make a new folder and call it input. Okay, because we're not dealing with graphics anymore. We've done a lot of graphics stuff. Let's now start dealing with input, and this is keyboard info.cs. And again, we will put this now in our own namespace. But novice game library.input. And if I can type, and public class keyboard info. Maybe we have a few properties here. So one of them is the previous state and one's the current state, right? That's straightforward enough. Keyboard state. They need a getter and a setter, so this is then wrong character. Yeah. Get, it's a private set. Private set, and then current state, I think we'll just call this, right? Something like that. Don't need that. Holds information about current and previous keyboard states. Right, then this literally holds the previous frames keyboard state, because that's essentially what we're assuming, right? That we had a certain keyboard state in a previous frame, and we now need to compare that. So this is why documenting it as such. And this holds the current frames keyboard state. And let's do a bit of formatting, thank you. And then we need a constructor for this. That's straightforward. ctor, and do we take any parameters? No. Oops. And then we say, all right, okay, so previous state is a new keyboard state, right? Because it's an empty state at the moment, and the current state is basically just keyboard get state, yeah. So that's us saving that into them. And then during update, keyboard info constructor doesn't need to know much about it. And then public void update, not void, void. And I think we need, oh, we don't take any game time. Well, yeah, we don't need to know any delta t in this case. We're literally just interested in what are we doing during that update cycle. Right, okay, understood. So previous state is equal to current state. And current state is keyboard get state again, right? Current state is keyboard dot get state. Update keyboard states. All right. And now we have a few methods. Not a problem. Let me. We can copy these. Like these are very easy to understand, and I will walk through them. So, go and fix your code. Thank you. Let's start right after update. We have basically is key down. We look at a certain key, and this is where you basically just pass in what kind of key you're looking for, and it returns the current state of that key, whether that key is down, right? Because that's what we're saying. Is key up? Same question. Was key just pressed? And that's a bit more interesting because what we're returning here is the current state of the key and whether the previous state of that key was not pressed. And then basically this is the opposite of that, where we're saying was key just released, is the key now up, but was it pressed in the previous frame? Right? That's sort of the two opposite sides of the same coin of the question that we're asking about keyboard states. And that makes absolute perfect sense to me. God, now we do mouse things. So this is what's called mouse button. Well, this is literally just a little enum, literally just holding information about what buttons could be pressed. Namespace, novice game library dot input. Thank you. Public class, no enum. Sorry, I was literally just saying that. Mouse buttons, well, mouse button, and then we have left, comma, middle, comma, right, comma, X button 1 and X button 2. Standard mouse input buttons, right? And then this is the primary mouse button. This is the scroll wheel click, we'll call that scroll wheel button, because that's what it usually is, right? And this is the secondary, usually. Actually, let's usually, unless you're a southpaw, and that makes all the difference sometimes. And I don't like this actually, because we're right now already assuming that the buttons will only be used in this one way, and it's always the left button that will take that input. How are we going to check then? Hey, how do we like swap mouse buttons? That'd be the next interesting question. Like I would. Okay. Not gonna worry about that right now, but I feel like I want to change this in the future. And these are normally like side buttons, like thumb buttons, right? So we'll call this the first thumb button. And this is the second thumb button. I don't know, I only work here.
You can
Okay, now we are making another class. Oh god, this is all wrong. I think what I would just end up doing in the actual game, make another little enum, primary, secondary, like for those two buttons. Yes, yes. Well, I think it's all about making assumptions, right? Because 75% of all people apparently are right-handed. I don't know the actual number, by the way. That's just me shooting in the blind. But we don't care about the other 25% and let them struggle. Like, I see this so many times in games because my wife's left-handed, and there's so many games she just really struggles to play because you can't change a fucking assignment of those buttons half the time. It's really annoying, but this is what I'm trying to do better. But okay, let's make a mouse info class. We need to retrieve some mouse information. So again, we make our own little namespace, or we live in our own little namespace, I should say. Public class mouse info. Off we go. Then what next? Okay, so we have previous state, current state. That's sort of the same thing again. Okay, interesting. Let's just mouse state. Yeah, is previous state. And again, we do this with a getter and a private setter. And public mouse state, current state. Again, with a getter and a private setter. All right. Holds mouse state in previous and current states, conditions, current frames. Makes actually make more sense that way. Holds the mouse state of the, my god, my typing, of the previous frame, and this is holds the mouse state of the current frame. Okay, that's that part. Then what else do we need? Properties for handling cursor position. Public point. What's a point? System drawing. No, this has got to be from XNA framework. Right. And what is a point? It's a struct of probably just X and Y. Yeah, there's the two data members, and you could actually also return 0. That's just an implementation that they've done. But here, this is basically just an X and Y. Okay. So public point position, is that? Okay. So interesting enough, we can actually in the future set the mouse position as well in game. That's. I mean, you could use that to like jump to buttons, right? Like force focus somewhere. That's actually cool. So we just call it position, and it is, my god, okay. Get is current state dot position, and set. How is that going to work? Set position. Okay. Check position. I don't see you. Unless we, that could be a function that we make ourselves in the future. I'm not seeing you referencing this. We'll see. Set position value dot x comma value dot y. Yeah, that's going to be a new method. I don't see him saying, oh, here's a library that you use for that. Okay. public int x get current state x and set would be probably set position again, right? With value, okay. Set position with value dot x. No, value, sorry, value, comma, current state dot y. Right, okay, yeah, because we're only setting x, so that's the only value we're actually putting in, whereas y would remain unchanged. Understood. Which basically means we copy the x just like that. Oh, yeah. Because then this is actually referring to y, and this is current state dot x, and we pass it as y the value of whatever setter we got. Right? Cool. Gets or sets the current position of the mouse cursor in screen space. And this is only for the X position, right? Gets or sets the current X coordinate the mouse in screen space. Yeah, the mouse cursor in screen space. Oh. Must pin that in there, or paste, I should say. Jeez, okay. Update this button down, this button up. I'm still missing. There's the set position. My God. Okay, we still have a bunch of stuff to do here. So mouse info, we got the position stuff. Now we have some more properties to set. Public point. Let me actually grab the documentation for that. Jeez, Sebastian, what's with your keyboard today? There. Point is position delta. And you take, no, you just do a return. Current state dot position minus the previous state dot position. I mean, that I get, right? That's literally what a delta is. It's a difference. It's a difference between one number and another. So, right, we literally just take the current position, we take away the previous position, and then we have. Yeah, actually, that tells us exactly as a vector how far in relation to the previous state we are moved. Okay, cool. So it's not actually about absolute positioning, it's actually about that movement between 2 points without necessarily needing to know where exactly those points were. That's cool. And these I'm just going to copy because they are that straightforward, except for maybe the last one, but we'll look through it. So x delta is exactly this same thing what we've done with the position, just on the one axis, the same with the y delta. All right, yeah, okay, that is super straightforward. We basically say true false was moved. That result comes from look at position delta, and if it is not 0, then obviously something has changed. Otherwise, you would expect x and y delta or position delta to always be 0, 0. So if it's not the case, then we have moved. So just as an indicator for that. That makes sense. This is just scroll wheel stuff. Literally just a copy of what we've done previously. Nope, excuse you. So this I don't mind copying because again, this is very self-explanatory. We have the scroll wheel integer, which is the current state of the scroll wheel value. Okay. Since the start of the game, gets the value of the scroll wheel between the previous and the current frame. Again, this is just, pardon me, delta. And then we need to construct this now. So CTOR, let me go and, yep, mouse info. You didn't take in any parameters. I'm happy about that. Constructs a mouse info instance, or yeah, instance. And all we need to do is previous state is new state. Is a new mouse state with no real information, and current state is mouse state get state, or just mouse get state. Sorry, mouse get state. I should have thought about that. Okay. And then we have an update method, which is very straightforward. So let me public void update. And so when you see a void in this thing here, like let's look through like this function declaration. Here we're actually saying we return an integer, and public void update means we don't actually have any return. Okay, this function does not expect to return anything, so you don't even need to put its output anywhere. There is no output. Same as it doesn't take any input, what's between the brackets. And all we're saying here is previous state is the current state. And current state is mouse get state as usual. Okay, yes. Oh. Current state is mouse.get state. Yeah. Update state mouse state between frames. Right? Public, what's next? Okay. This is a bit more interesting now. Public, well, let me go and grab the documentation for that function. Is button down, and this takes in a mouse button called button. And it returns true, so if the specified mouse button is currently down, otherwise false. Okay. Will you switch on button? Mouse button left. You basically say return current state left button. Right. You make a comparison whether the current state of the left button is being button state pressed. Okay. And you should return false. But obviously there was no button pressed in that case, so case mouse button dot right. Or middle, even it doesn't. Let's go with the middle button first. But actually I can we just copy paste this a couple of times? So middle right button and then the other two extra buttons. So basically just formulating out the case switch case here. X button 1. And then comes the is button up, which is essentially the same thing. Let me just copy you and see if I can put this together myself decently. Is button up is the question, right? I don't know whether the special button is currently released. It's currently released, otherwise it's false. Okay, and then it's not button state pressed, it's button state released. I think that's literally all we're doing here. Okay. I would love to mark more than this, but I don't think that's going to be a thing. Maybe. Oh, released. Ooh, I love me that alt clicks. I think that's it. Yeah, that's literally, it was just the opposite of the is button down. Cool. Ah, okay. Do the same, and returns a value that indicates whether the specified mouse button was just released, right? Pressed or, yeah, but it was just pressed on the current frame, yeah. So, was button just pressed? Without the caps lock, maybe? Is current frame. Was just pressed. Otherwise, it's false, okay? And this is basically just going to be released, like previous state, released, current state pressed, right? Yes. So current state is pressed, but, and previous state dot released, no, yeah, previous state dot, would probably need to do right button dot, no, well, I'm being silly here, am I? Okay, this is a bit of a bigger expression. Let me go and copy that one time, and then we'll try and break it down. I sort of understand actually what's going on. It's two if statements bundled together, I think. So basically what we're saying is return the current state left button, whether it's pressed, and previous state left button equals released. So this is where I went slightly wrong. And then this is for the middle button. Nope. This is the right button. Yep. X button 1 down, drop button there, and that's X button 2. Now we know whether this button was just pressed. Okay, cool. What else do we need to know? If the button was just released. So that is pretty much the opposite to what we've just done. Let me grab this entire function block, bonk it in there, and why are you complaining? You want an empty space there? Sure, I guess. Was button just released? Is the other question, right? All right. And essentially it's previous state left button released. No, I think all I need to do is just say released up here. So current state is released and previous state was pressed. Actually, let me see if I can released, yes, and then we go here. Button state pressed. Right. And then we finally get to the set position, and then that should actually finish us off. Ooh, I like finished off. I mean, never mind. You go away. My God, my typing today is slightly shocking, but it's fine. It's a void. It doesn't have a return position, and then you probably want a point. Oh no, you just take int x and int y. Okay, sure. You could probably also do it with a point. It wouldn't actually matter all that much. And then we say mouse.set position. Get you that x comma y boofed. And then we say that current state y. All right, we're actually overwriting the current state. Instead of waiting for the update to catch it in the next loop, we're actually saying right now, no, wait, the current state is now including those new coordinates. New mouse state, I think is what we're needing here. And it then gets initialized with a whole bunch of variables. So x, y, and then current state dot scroll wheel value. Current state dot left button, current state middle button, current state right button, and get the other two buttons as well. So current state dot x button 1 and current state dot x button 2. And then that should be that. Let me go and format that because that's a terrible line. And that finishes off the set position function. And okay, we basically have dealt with mouse stuff. Now comes gamepads. So this is a gamepad info class, gamepad info.cs. Belongs to input. Public class gamepad info. Holds information about, I think, also current and previous states, right? Let me just check through the description here. Yeah, we're also doing the current state and previous state. A gamepad's current and previous states. Okay. Right, the first one literally I'm just going to copy because it is that straightforward. We spoke about this yesterday actually, and this is essentially just referring to the fact that you can have up to 4 gamepads, possibly more, I don't know, but usually you see 4 little segments on the Xbox gamepad, so I am assuming it's designed for 4 players. And this is the player index. You literally just give them the player gamepad that you're looking for specifically at that time, which is why we're needing this player index, right? That's super simple. This I'm just going to copy. We've done this now a couple of times. It's just getting the two states and then like save them as a previous and current state. This is a very simple rule. We're basically just looking at the gamepad saying, hey, are you connected? Right? And again, if we look, actually, these are gamepad states, so, you know, we should have... Also, you probably want me to import or using these, and what are you? It's also XNA framework. Okay, just missing a couple of libraries up here in the usings. But this is very simple. Okay, copy this. Again, very straightforward, nothing to really understand here except for variable assignments. Basically saying here, and interesting enough, we're looking at these sticks, left thumbstick and right thumbsticks. They're actually saved as a vector too, so that's basically a variable that holds information about the X and Y at the same time. Then we look at the left trigger, and this is sort of important to know that the left trigger doesn't just look whether it's been pressed or not. You notice maybe in some games where you can just sort of hold the trigger in halfway and it maybe goes on a half speed if it was a racing game. And so this is represented by a float. Again, this is a number between 0 and 1 with all the numbers in between. So 0.11111, like it's almost 11%, like something like that. And that's just how they store this. Like, makes absolutely sense. Here's the constructor. Yeah, nothing special here. Make a previous state, make a current state. You are not happy there. Why? That makes no sense. Hey, Control Shift I, go and format this properly. If you have complaints about formatting, fix the formatting. 2 seconds. Close code and open code. And we're coming up nearly, well, not quite yet, but we still have some time, but we're coming up to my break time already. My God. Okay, now you have no complaints. Sure. And what methods do we have? Update, okay? This I will actually type out because it's a little involved and I think we want to make sure we understand this properly. So let me go and grab the documentation for it. And so it's a public void update. And it takes in a delta time. I would almost assume so. In this case, game time, just game time. Or we could call it delta time, doesn't really matter. And so what are we doing here? We look at the previous state, we save it, we take the current state and save it. Okay, and then the rest is to do with vibration. So let's do the previous state. Is God, it's current state. And current state is gamepad info, gamepad get state. Ah, right, okay. Get state, and this is where we then pass in the player index, basically saying, hey, which English, which gamepad are we looking for? Yeah, player index, capitalize P. Then what was this? If vibration time remaining. Okay. I forgot something up here. We forgot a little private. And time span is coming from using system, right? And then this should now finally vibration time remaining. So what are we actually want to see? If it's less than 0 or if it's like 0? Well, greater than. Right, okay. If that is greater than time span 0, basically meaning we still have vibration time remaining. Yes, I understand that part. If we have that, then the vibration time remaining is, oh, we subtract game time, elapsed time, elapsed game time, basically making sure that the counter for the vibration, however long we wanted it, actually gets counted down, decreased, and at some point it's 0. Cool. And then inside of that, we're saying if vibration time remaining is small or equal to time span 0, then we stop vibration. Not a function that exists yet, that's fine. These I'm just going to copy. Like this we've done now a couple of times with the keyboard and mouse states, where we just look, is the button down right now? Is the button up right now? Or was it button just pressed, meaning we look at the previous state being up and the current state being down? Or was the button just released, which means we need to look at the current state being released and the current previous state being pressed and the current state being released. Yeah, this button up. Cool. And then set vibration, stop vibration. Oh, that's straightforward. Quite literally, look at this. Set vibration takes in the strength and how long. And here's sort of the definition of a float properly, between 00f and 1.0f, and the amount of time. I would like to think. Wait, no, 2 seconds. I think this is in milliseconds. I'm hoping it's in milliseconds, but we'll probably find out when we start using it. And I have a gamepad connected, then we will probably see things happening. Anyways, not important to testing. We now need an input manager. We need someone to manage all these 3 different inputs and, present them to us in one nice interface. So this is called. Oh, it's a perfect time, actually. Yes. So here's our input manager. Let me just quickly make the boilerplate for it. Namespace is novicegamelibrary.input and public class input manager. Yes. And so after the break, we will go through, we will figure out how this input manager works, and it's actually fairly straightforward. Here we have the 3 properties, which is the keyboard, the mouse, and the gamepad. We then, in the construction, create those new information structs, make this, all right, okay, well, we were actually looping through all the available gamepads, make sure we can grab all of their input, all their states, and then update is just that. Okay, that seems fairly straightforward. But yes, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. I will be back in 3 to 5 minutes. and then we shall continue our journey in learning some programming. With that, I shan't be long. Yeah, kinda. And with that, I am back. So let me go and finish my brew quickly. If I'm getting offered a fresh brew, of course I'm going to take a fresh brew. So,
To leave it on my desk.
next to your keyboard.
Alright, okay.
Eh. But anyways, we are making now an input manager. Yeah, we're just going to copy paste this shit. I'm honestly not too bothered here. This is literally us just making a keyboard, a mouse, and a gamepad info struct, or a variable, no, a member property. Get the names right. You will see me doing this a lot. I will get my words wrong, but um, but it's just a matter of figuring it all out bit by bit and learning the proper words slowly but surely. This is the constructor, which again, there's nothing special here. We're basically just saying, hey, we have these, members, or sorry, properties. Now actually fill them up with a new keyboard infrastructure, a new mouse infrastructure, a new gamepad infrastructure, and they're not structure, they're objects, whatever. But for the gamepad, go from 0 to less than 4, so it stops at the 0, 1, 2, 3. That's basically the fourth actual gamepad, but it's the index 3 that it's going to stop at, and that way it has then all Oh yeah, wait. You're missing a class. You're just missing essentially the XNA framework. That's what it is. Right. So that's the constructor, and then update. We're literally just calling update into every single function, into every single one of our input classes. Right. Let me go and format that. And literally, as we're saying update, we take in the delta time and we call keyboard update, mouse update, and the gamepad updates 4 times, obviously, for all the available gamepads.
My Kindle. That came off my Kindle. Okay, it was just a case.
I know. A little bit of soap will take it off. And okay, interesting. Now we are actually including all this in our core class. And what are we doing? We are, let me, graphics device manager, graphics device, sprite batch, content manager. After that, I will make a public static static input manager. Hey, Silly River, how you doing? Welcome in. This is from this is called input, and it has a getter and a private setter. Of course, we need to document this. Holds the input manager instance, right? I can't say I've ever heard of that. I've heard of quite a few games, but not that one. And then we have a public static bool, and this is where we now basically check, basically doing exit checks. This is actually quite cool that we're starting to do this now. Oh, right. I didn't realize it was shortened like that. I actually assumed there was a game named Thug. And would it be so weird to have a name named Thug too? I don't know. But no, I've played Tony Hawk's. I always sucked at it. I know that much, but it was fun. It was one of the most fun games ever. Exit on escape. Is a getter and a setter. Thank you.
Just clean up that.
Thug. THUG. No, I can't say I was ever good at any of the skating games. Ever. My headset is doing things. 2 seconds. Trying to keep the cabling from my neck, and sort of I've wrapped some twine around it, and it was coming undone, and I didn't like it. Yeah, like speedrunners, that's a complete different matter anyways. I would never try and compete on that level. Jesus, not. And this is basically just, it gets a set of values. And should the game exit when the user pushes escape? Like literally, don't have to make that a really long one. And this should never end up being 0. Just trust, no? Just trust me when I say that won't be 0, okay? Escape, no, exit on escape enabled. And we literally say exit on escape equals true. And then we make a new input manager, create a new input manager instance, and this is input manager equals new input manager. Right, just like that. Okay, and then we need to update, change update a little bit. We just called it input. And where's my update? Cool. Oh, right, we make actually a new update function here. Interesting. Interesting. Let me go and grab the... No, we'll need to do this ourselves. So this is a protected override void update. So we are overriding our normal update thing, and base update game time is happening still. And then what are we actually doing in here? Update the input manager. So that is input update, right? By game time. I'm gonna pass that in. Just no, it won't be. Update game information between frames. Because this is the thing, like the update doesn't actually do any draw calls, it has nothing to do with the graphics. This is all stuff that happens in between frames, and only when we call the draw call do we actually do any actual output to the screen, drawing, whatever you want to call it. And then we say if exit on escape, and input.keyboard is down, is key down, keys escape dot escape. Oh god, I don't want all this here. Do an import, please. Yeah, this doesn't look right. If that is the case, then we do exit. And then we do base updates. Okay, so now we need to change our game itself to actually integrate all of this. So we don't need the core, we don't need the input manager, we don't need mouse info, mouse button, keyboard info, we don't need any of that, we need the game right here. So where do we start here? Check keyboard input is now changing. Don't need that. We need the float for the movement speed, and it's not keyboard state, it's input dot keyboard is key down, key space, right? It won't be, just shushed. Input dot keyboard is key down. Let me actually go and copy that. Like, we should be able to just replace this carefully. Right. Okay, now we do the same for the gamepad, so it's not. Wait, I feel like. All right. Okay. No. I see what we're doing here. So no. But what we are doing now is we make a new gamepad. Gamepad info, player one. Or we could call this gamepad one, but we'll call it player one. Or so I'm gonna keep it the same as in code, just so we are not running into weird issues later on. That is equal to. Let me fix my microphone here. So that's input dot gamepads dot. Wow. Gamepad. So we are basically needing an index into an array. We are casting to an integer the player index dot one. Turn it into a number essentially. You shut up. It's fine. It won't be null. I mean, seriously, if our input manager is null, then we have serious issues because then it didn't manage to find a keyboard, it didn't find a mouse, and it didn't find a gamepad. Like something would have gone terribly wrong then already. And then this is gamepad one. That's my fault, because this will not accept a player index. It can't. And then we're doing time span from seconds. We'll give it 1 second vibration, so to speak. Else time span 0, something like that. Oh no, it's just stop vibration. I'm an idiot. We have our own function for that. We even made it. I was there. Gamepad one left thumbstick. So basically we're saying here the x position is that plus or equals, yes. So if the left thumbstick is being pushed in any direction, right, we on the x add the x component plus the speed for gamepad 1 on left thumbsticks, and then on the y it's minus, but again, because we're actually looking at the top left origin instead of bottom left, is why we're going minus here to increase that y. Else gamepad 1 there we go. That now takes care of the gamepad things, and I think that's it. Also, I feel like we have something in update that we don't need anymore. Where is it? This here. This is not required anymore because we're now having our own exit check. Where was it? Keyboard. No? Sure, we had a thing where we even checked whether exit on escape was true. I think this is actually in core. But this isn't needed. Yeah, we're not doing any of this anymore. So let me go and grab core quickly, just so I understand where. Yeah, this is here in our update. We do this check, and then base updates would refer to core update. Yes. Okay, that makes sense then. Okay, so that's why that check ain't needed there anymore, and we can save. Let's make clean. I think I want another console here. No, that's the wrong. Learning MonoGame. Clean. Make run. Missing XML comments, sure. But yes, we have the same exact functionality as before. We can move our slime around. Escape still does the thing. Fantastic. So I want to quickly check something here. Can we... check keyword input. I want in keyboard input. I want to do a quick test if we can maybe... If input, just trust me, it won't be 0. If the keyboard is key down Q. Hey, you're motivational. How are you doing? Keys dot Q. No, wrong button. That's not what I was looking for. Is full. Nice to hear. Good to hear. I'm trying to figure out if we can somehow switch between full screen and not full screen. So because we're putting in false here in this constructor. Graphics is full screen. That's what I'm needing. Graphics is the graphics device manager. But I can't refer to that, can we? I think... No, actually, I should be able to. Wait, where is it? Is it there? So can I say in that case... let me go down. Where is the check? Graphics dot is full screen equals true. Right. Actually, I need to be a little bit smart about that because what we need to say, if the input is F for full screen, right? This is a test, and graphics is full screen equals false. So if we're not in full screen mode, go into graphics is full screen true. Else, no. Basically need to do this again. Just ask the other way around, I think. And graphics is full screen true. I'm sure there's a better way of doing this. But I'm really just doing this for testing whether we can just switch between full screens and not. I do apologize. Spam. No, not even spam. It's literally rubbish. I'm doing great, by the way. Yes, thank you for asking. So I got carried away there. Now, either this is going to go terribly wrong because we're writing somewhere where we shouldn't be writing, and you know, I like touching memory in cases, or it'll just work. Nah. I mean, you're taking this, but F doesn't do anything. Okay. Okay. Oh, I think I know what's happening. Wait. I did see a call in graphics to apply changes. Does that make sense? Maybe we need to like really say, okay, we have a different state now. Now make sure you recalculate that whole thing. And I'm in the wrong window. We're just going to do this. Well, it's trying, but I think this is because of my tiling manager where it's falling over. But maybe, haha. If it's not full screen, we want to go full screen. Let's also make a new resolution. Dot. Preferred back buffer width and back buffer height could be a thing, but I don't. Oh, hello. I've been doing things entirely too complicated, it turns out. All we need to do is check for the F key. And it turns out I can apparently just say, hey, switch full screen? No, toggle full screen. That'll be a method call. Graphics is full screen. Don't even need to set that. And do we need to apply? I don't know. Maybe we can get away without doing the apply settings, or maybe we do. We will see. It's trying, but this is I think to do with my tiling window manager. Actually, let's test that hypothesis, because all I should need to do if I make it a floating window, I may then be able to change. Okay. Nah, you're not. Oh no. We're getting there. We're actually making full screen. And then yeah, it's being weird about it, but it's fine. That was literally just me fucking around and finding out, I guess, right? I was curious if we could do things like that, but just figuring them out ourselves somehow. But yeah, that actually finishes off chapter 11. Would you believe it? What I would like to do quickly is have the formatter just go through C sharp here, Sharpie, that's literally what it's called, I thought. 2 seconds. Yeah, code formatting. Maybe that's exactly what I should format document. That's also not what I want. I was actually hoping for you to just format all the open documents or something like that, but you're not going to do that. Okay, fine. But yeah, save this. So this is chapter 11 done. Let's go and implement it. Input manager. And that's actually it. As we just made an input manager. Yeah, there's not much more to say to that. And push that out. We can then go and see this probably as an activity here. Oh, wait. Yeah, that was my fault. I wasn't fast enough in entering my passphrase there. That should be it now. And indeed, let's make a new pull request into main. I don't think I'm going to make a long stream today. My ear's getting really sore already. So we'll see how it goes. Yes, create a merge commit. And then let's make sure we are now obviously checking out into main. Pull that all in. Sweet. And now we go and branch off into chapter 12. Yeah, if you want to push that out. And that is now, oh wow, now we're getting into actual game stuff. We're going into collision detection. And like for us, that means we shouldn't be able to leave the game field. And, you know, if we were to run into a bat, something should probably happen. And we should discuss what collision detection actually is. In 2D games, collision detection involves checking if two objects interact with each other in some way. Simple to complex. So proximity collision detection is the simplest form. It's checking if objects are within a certain range of each other. That's basically when you need to know that if they are near each other, okay? Simple shape-based collision detection is detecting checks if two shapes overlap. The most common and simple shapes used are circles and rectangles. To find the distance between, oh god, it gets very mathy here. Circle collision detection is computationally simpler check than rectangles. There are also no special considerations if the circles are rotated. The circles rotated don't make a difference because they're rotated around their center axis, so it doesn't matter. Makes sense, right? If two circle shapes are overlapping, we only need to check if the square of the sum of the radii between the two circles is less than the square distance between two circles with the following font. What? Okay. To find the distance between two circles, imagine drawing a line from the center of one circle to the center of the other. The length of this line is the distance, but we could also calculate it by first walking up or down and then walking left or right from the center of one circle to another, forming a right triangle. So alpha down here is the horizontal distance between the centers of the two circles. Okay. Beta, or B, I think it's beta, is the vertical distance between the centers. Right. And C is the total distance. Wait. C should be essentially, no, actually C squared is A squared plus B squared, right? Is that what we're coming at here? Because Pythagoras. I remembered stuff from my old school times. Why, yes. Okay. So that we know the distance. Because we can look at... Yeah, we can look at the x position of two circles. It doesn't matter where on y they live, because we're just interested in this distance. Okay, that gives us 1, that gives us a. And then to know b, we do the same on the y-axis. Square those two numbers, and then that gives us the total distance between those. Right. To check for overlap of two circles, we compare whether the squared sum of the radii of the two circles is greater than the squared distance. Why the squared radii and like radius of circle 1 plus radius of circle 2 squared has to be greater than a squared plus b squared. When the squared distance is 0, to calculate squared distance. So we actually get a little bit of a helper here to do the mathing for us. This distance squared thing, vector 2 distance squared is circle position of, so circle position and circle position 2 is this thing. That's basically this calculation here, this first part. Okay. No, it's not. No, that was actually this part. Distance squared is actually the c squared, if I understand this right. And the radii squared is this first part, so radius of the radii of the two circles squared. Sure, we could express this better. Although, no, this is actually probably the cheapest operation because exponent or power or whatever is probably going to be more expensive to do in hardware. And the circuits overlap because 100 is greater than 125. So let me try and visualize this somehow. So we have two circles somewhere, and we know their radius, which is this 5 plus 5 squared, which is 10 squared, which is 100. Okay, that I can follow so far. If we do the Pythagorean for the distances, we end up with apparently 25. I suppose trust the math, okay? Okay. Interesting. So they actually have two functions here. One is distance squared and one's the distance, which returns the distance by providing the square root of the distance squared. So why not use this instead? Square root operations are more computationally complex for a CPU. So instead of getting the normal distance, which would require the square root operation, it is more efficient for the CPU to multiply the sum of the radii by itself to get the squared sum and use that for comparison instead. Yeah. I mean, square root operation is really expensive, more expensive than division, as a matter of fact. So I can see why they would do that. The rectangle on the left is axis aligned since both the axes are aligned with the screen axis. The rectangle on the right is non-axis aligned. Yeah, it makes sense because it's rotated. So you actually have an intersects method, which basically would see whether the two rectangles are intersecting anywhere. So like this would then... Complex polygon collision detection uses a method called separation axis theorem to determine if two polygon shapes overlap. SAT uses more complex calculations that can determine if any polygon shape overlaps with another polygon shape, including if they are rotated. Yeah, implementing SAT is out of scope for this tutorial. If you're interested in further reading about this, please see the following articles as a good starting point. Let's just have a quick look at this. So this is actually like pentagon, hexagon. Hexagons are the bestagons. So you are aware of that collision. That's cool. I'm looking. I want to see the map. God, what is this? Points verts in the geometry. Get the perpendicular axis. You need to loop over these. Normalize the axis by making the length to 1. Jeez. Okay. Vector dot product. This is advanced math, at least for me. Wow. Yeah, this is way above me at the moment. So let's keep it simple and simple and cheerful, right? Let's just go through until we are making code. This is all just literally showing off different ways of doing this. And this is actually now where we start. Okay. We're doing this circle-based detection, which is the easiest to do from what I've read there. I don't want this in the root of the game library. No, 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 no. We are in the branch. Good. What I was thinking in that case, I think we'll call the folder. Is it a primitive or an atomic? I don't think it's an atomic. An atomic is something like integer, boolean, like the smallest variable type that you can come up with. I think this is going to just be a primitive. So primitives, or primitive, yeah, and primitives. My God, I can type primitives. How else would I describe a circle? Shapes? But this is to do with collision detection. Like how are we continuing from there? I almost want to call this maybe physics. I think shapes might actually work for now. Okay, and in here we're making a new file, and that is circle.cs. Okay, and so namespace Novice game library dot shapes public read only struct circle equatable no. Using system, you should be fine. Why you know? All right, okay, because we haven't actually implemented the member that is required to make this fully work. So because we have derived from equatable, it requires us to implement a function called equates, I think. Equatable, so yeah, dot equals. So we can't do a comparison because it doesn't know how to do a comparison. That's fine. Yeah, I think I'm gonna have to call it soon. So a private. Why a private static? I guess because that's what you actually store the circle in, right? And then XY radius, that's, we're just going to copy that. And then it has a property of location, which is just a point of X and Y, so make sure we're getting that from the XNA framework. Okay, so what are these? What is S empty? Right. Okay, right. We're making an empty circle. You basically have a prepared thing for an empty circle because you need one with X, Y, and radius all being 0. Okay. And to see whether it's empty, you make a comparison. Well, you make a Boolean saying is X equals 0 and Y equals 0 and radius equals 0. So all three need to be 0 for that to be true. Otherwise, if any of these is greater than 1, or not 0, I should say, then this will always return false. That makes sense. We have more properties. Let me look at these quickly. Gets the y coordinate of the highest point on the circle. How are you doing this? So you are going to say top is y minus radius. So you take the y coordinate and you just you add the radius, or you take a radius away if you go left. Yeah, okay, that makes sense. Because we're only moving the half the diameter, the radius, in that direction to find the point for that, okay? And then we have two constructors, apparently. Let me go and look at those. Right, so either you give them an X and a Y and a radius, or you give it a point, which also contains an X and Y, but it's a single variable, and the radius, which then extracts those X and Ys out of there. Okay. So how does this work? This is actually the mathing part that says what's a radii squared is this radius and the other radius. So basically you're doing an intersect between a circle that you've already got in yourself and then another circle that's being passed in. You literally add these two together, times them to each other, and that leads you to get the radii squared. Distance squared is vector 2 distance squared, this location and the other location, right? The vectors for that. And then you basically say, if distance squared is smaller than radii squared, then you return, well, it's true if the distance squared is smaller, but if the distance squared is larger than the radii squared, then it's false, which means they are not intersecting. Right, that makes sense. And now we need to do the I-equatable interface implementation. And this is how it does this. So equals. How are you doing that? So we have one read-only equals. It returns bool, which is Boolean comparison. God, this is a. So if this is x's is the same as the other x's, again, where we're looking at another circle, like that's what's being passed in, we're also referring to our own circle that we are currently holding, okay? And we compare its x, its y, and its radius. If they are all equals, then, you know, it's equaling. But we then do an override. Object is circle, other equals. Right, so you're basically just calling into this function with this overload. So you just take in the whatever circle and object, if basically saying make sure it's actually a circle, and it does the equalization. Like it's they're both equal. Okay. Returns the hash code for the circle. I don't think I know anything about that quite now. I know that hash tables are a thing, and it's a way of holding onto information without needing to know a key, or I don't exactly know, but we may find out. Returns the value of the circle on the left-hand side of this equal. So basically, we're implementing an equals equals and a not equals operator here. And it says left-hand side, there's two circles. And the result is if left-hand side equals right-hand side. Not equals is, yeah,
Stop.
exact opposite. If left-hand side doesn't equal the right-hand side, you know, return the boolean for that. Okay, cool. No, I can't, guys. I'm sorry. I'm gonna have to call it. This is killing me. Let me go and commit this code. Implemented circle shape primitive for collision detection. Yeah, I'm so sorry, but no, this is not gonna work. Let me see if I can read out, because it wouldn't let me yesterday, and there seems to have been a bit of kernel issues with Archie yesterday. New kernel came and it was all good though. Let me go. Thank you, Safa. Yeah, might as well. We go and visit Monsieur le Discount Engineer. I think that'll do nicely. Let me go and turn that down for a second and see if I can get a raid out. If I can get things. No, not raid. And the raid is being prepared. We should also get a custom message if you want to copy it. There we go. And maybe even just up to there. But yeah, I'm so sorry for calling it early today, but it's my OR is really giving me jip. And so I will be back on Monday. I don't know what we're doing yet. Could be Factorio, could be more programming. We'll see. Guys, thank you so much for checking me out today. I will be back, as I says, but yeah, I can't concentrate at the moment, so it is unfortunately what it is. But with that, peace out and bye.